Hi, everybody. Welcome to this month's office hours, how to integrating Gremlin with your observability tools. Sorry. Some quick notes before we get started. This is an interactive webinar. If you've come to these before, you probably know that. You've heard it 1,000 times, but it's worth repeating. We want to hear from you as much as you want to hear from us. So again, if you have any questions, thoughts, comments, feel free to drop them into the Q&A or the chat panel, and we'll be happy to get to them. After the presentation, we'll go through the questions that we see in the list and answer them in real time. You're free to ask more questions as well during that time. Again, this time is for you, so please don't hesitate to ask. This webinar will be recorded, and the recording will be made available afterwards. So if you'd like to watch it again on demand, you'll be able to do so. And if you're new to office hours, welcome. This is a monthly series that we do where we cover different features in Gremlin. If you want to sign up for future sessions, or if you want to see what we're going to be covering, you can go to gremlin.com/office hours to check that out. I'm Andre Newman. I'm a senior reliability specialist here at Gremlin, and I'm joined by Jason Heller, director of our technical services. Again, we're here to answer your questions. Jason's in this stuff all day. He knows everything about observability, or close to everything. So again, this is the time to ask about this. So a quick look at our agenda today. I'll just do a quick introduction talking about what observability is. I'll talk a bit about how observability and reliability testing and reliability in general work together. Jason will show us a really cool demo of using Honeycomb with Gremlin. And then again, we'll have that time reserved at the end for a Q&A. So if you've worked with observability tools before, which you all probably have, a lot of this might seem pretty basic. I just really want to make sure that we're all starting on the same page. And this will also help explain a lot about how Gremlin's integration works the way it does. So just bear with me, this will all be worth it. So what is observability? In its simplest form, observability is the ability to measure or understand a system's current state by looking at the data it generates. Of course, modern systems generate a lot of data, so observability focuses on three main categories or pillars. Metrics, which are the numerical measurements like CPU usage, memory usage, disk usage, and request throughput. There are logs, which store structured data about specific events like HTTP requests or like something performed by a process. And then there are traces, which describe events spanning multiple services, like a user performing an action in an enterprise application, for example. Each of these can be implemented independently. For example, if you're a developer, you've almost certainly used logs to troubleshoot bad code. But you probably don't look at metrics too often unless you're testing performance. The real value comes from combining these three in a way that works and also provides useful information. Using logs and traces together lets you identify specific events and trace them to their origin. Metrics can help you understand what the impact was to your system. And altogether, they create this comprehensive sort of holistic view into a system. So really, that's the end. That's what observability tries to accomplish, is helping you understand why your system did something that it did or why it behaves the way that it does. So why does this matter? Why do we care what our systems are doing? Well, for one, systems are unpredictable. They have these emergent behaviors that we don't expect, and that includes failing. Two, systems are confusing, especially today's systems, which are these massive, interconnected, distributed environments with millions of moving parts and all these different services and dependencies and all sorts of fun stuff. And third, observability tells us how we can expect the system to behave over time, so we can make predictions about things like performance, scalability, and reliability. That's how these massive enterprise systems are able to respond to sudden changes in user demand. Think things like Amazon during Black Friday, or let's say, I don't know, an observability tool when a new enterprise customer joins. You have a lot that you need to scale up, a lot that you need to be able to handle. And in order to know that you can do so, you need to understand how the system works. So to achieve this, we need to ask questions that only our observability data can answer. Questions like, how is my application performing? At what point do I need to scale? What was the root cause of an error? And how does this impact the user experience? That's really the main thing. How do our users experience our applications or our services? Are they happy with the performance, or are they getting upset and leaving? And I just included this really great quote from Charity Majors, who's CTO and co-founder of Honeycomb. You can't predict what information you're going to need to answer a question that you also couldn't predict. So you should gather as much context as possible all the time. So now I want to talk a bit about how reliability fits into this picture. I won't talk in detail about why reliability is important, because if you're watching this, you probably already know why. And if you've seen previous sessions, I've talked about it dozens of times, and you're probably sick of me talking about it. But the real reality is that in order to start improving reliability, you need at least some observability. This is because reliability requires you to understand how your systems and services are behaving under these different conditions, and observability provides that understanding. It helps you do things like know the current state of your system in an objective way, set baselines and targets for reliability using actual concrete data and not just assumptions, and also detect and anticipate problems so that you can raise alerts and notify the right teams when needed. So to put it as succinctly as I can, observability creates a foundation that you can use to build your reliability initiatives. It's using those three pillars that I showed in the first slide as a jumping off point for your reliability work. And taking this and looking at Gremlin, the way that we use observability is mainly via health checks. And if you're not familiar, health checks are basically automated checks that Gremlin performs whenever you run a reliability test or a scenario. During the test, Gremlin periodically runs these health checks to determine whether your service is in a healthy state. If it is, the test keeps running. And if it isn't, Gremlin will stop the test and mark it as a failure. So not only is it a way to make sure that your service is still reliable and still available while the test is actively running, this is how we set our criteria for pass or fail too. And the really important thing about health checks is that they can be literally anything. In this example, I have a health check called a Bank of Anthos front end that sends a request to a super secret URL that I blanked out. I configured it to check for an HTTP 200 status code and also a maximum response time of 5 seconds or 5,000 milliseconds. So whenever I run a test on a service that has this health check added to it, Gremlin will ping this URL every 10 seconds and it'll compare the response against this criteria. And if any one of them becomes invalid, let's say this website returns a 500 status, Gremlin will stop the test and indicate which of these criteria failed. But this in particular is a custom HTTP health check. You can also use alerts, alarms, REST API endpoints. We also natively integrate with a bunch of observability tools like Prometheus, Datadog, New Relic, and App Dynamics. We have these native integrations to make it easier to be able to connect to your metrics or SLIs or SLOs. Whatever else your tool provides as an indicator of service health too will work. So for example, with Datadog, all you need to do is authenticate with an API key and then just copy and paste, or rather, you don't even need to copy and paste the URL for a metric. So you're able to search for your metrics from Gremlin, and we can just set it up for you automatically. Really, the key behind this is that you should be using indicators that you already use to measure and track service health. So if you have SLI or SLO metrics configured, those are ideal because, again, those are directly tied to your performance and your business. So they'd work perfectly as a way to track service health. But also, if you have alarms or alerts that you use to notify on-call engineers of problems, those work great too. And if you're just starting out and don't have any of those, even just a simple website check will work. So this front-end check is again, a simple HTTP check that pings a website URL. You can just start as basic as that, and it'll still serve you well for reliability testing. I also just wanted to highlight a new feature that we launched relatively recently, which we're calling intelligent health checks. The way these work is that if you allow Gremlin to read resources in your AWS account, specifically Elastic load balancers, we can actually map those load balancers to the services running on your EC2 and EKS clusters. Because we can see current and historical metrics, we can use this to automatically create health checks for you and also be able to set reasonable thresholds for failure. We try to make this as easy as possible. So if you're on AWS and then you authenticate with your AWS account through Gremlin, all you need to do is find a service that has an ELB, click this button that says use intelligent health checks, and we'll create health checks that track latency, error rate, and request rate automatically and with no additional configuration. This is just for AWS services for now, but we're looking for ways to improve and hopefully bring this to other platforms in the future. So just wanted to highlight that. So what does this look like in practice? So first, you start an experiment in the Gremlin web app. I have a super fancy diagram to go with this, it's going to be great. So first, you start the experiment in the Gremlin web app. Gremlin's backend servers distribute the experiment to your service. So for example here, I have Node.js as an example. This could be literally anything, Java, Python, whatever you might want to use. At the same time as this test is being distributed, Gremlin checks the service's health checks, figures out which observability tool to contact and which endpoints to monitor, again, based on the health checks that you set up. And every 10 seconds, it will check that endpoint to see what kind of state it's in. In this example, I just use Datadog because it's a very common one that our customers use, but this can be whatever you use in your own environment. So this process keeps going until the test is complete and for a little bit after the test finishes, or unless you hit the halt button and stop the test yourself. And the reason that it runs for a little bit after is that Gremlin will run a few more health checks just to make sure that your service was able to recover from the experiment and keep operating without problems. So that's kind of a high-level view of how that all works together with Gremlin and observability and reliability testing. So I talked a whole bunch and covered a lot of slides. Now I'm going to turn it over to Jason to give us a demo of how this works in practice.
All right, thanks, Andre. So let me share this up and we'll jump right into it. Okay, can everybody see my screen here? All right, awesome. So first thing up, I want to just kind of quickly go over the demo environment that we're going to be looking at, and then we'll talk through, the different observability integrations that we'll look through here and where we'll integrate them inside of the Gremlin product here. So first off, we're using this OpenTelemetry demo. It's basically a little web front end that's really designed to highlight a Kubernetes type environment with a series of containers and dependencies in here that we're going to use to basically buy little telescopes. So it's a telescope store that we're using, but the real reason we're going to use this is we want to go in and inject fault into this environment, and using the observability systems determine the health of the system while we're running these tests, right? And I think that's the connective piece that Andre was talking about, right? Is to kind of complete the picture on here, right? It's not enough to just do a fault in here. It's also leveraging the observability systems to determine what is the health of the system while we're doing these faults. So specifically for us, we're going to concentrate on the checkout service and maybe this front end service for the faults that we're going to inject in the system. And then we'll use Honeycomb for the example here, but we have a lot of other observability hooks that we can use to determine the health of this checkout service. So to get started with on the checkout service piece of it, if I look in the Gremlin side of it, there's a couple of entry points where I'm going to go look for running tests against the checkout service. From the reliability management side of this, I'm going to register my checkout service, which is a deployment in my Kubernetes environment with Gremlin. And then from there, we're going to create a standard set of tests that we're going to use to determine the reliability and ultimately give us this reliability score. These tests are set up by the admin of this team. We basically have a standards that we're going to run across this. So when I deploy this checkout service in our example here onto the environment, these are the series of tests that my application is assumed to pass when I load this on here. And I'm going to leverage the observability systems to really set the condition for this pass fail. So in the reliability score side of it, I have the scalability pillar, this redundancy pillar. Then I'm also going to run tests against the dependencies in this environment as well. But while I'm running these tests, the real key here is that I'm going to add in health checks into this. So let's add a new health check in here. Currently, I have a Dynatrace example on this that's checking out the front end latency. Well, I'm looking at specifically the checkout service, but I still want to know what happens if the checkout service has an outage in here, right, to the front end latency. So it kind of makes sense for me to say, all right, I'm going to add this front end latency check in here as well and make sure that if something goes wrong with the checkout service, it isn't interrupting the front end experience for a user. But for ours, we're going to specifically go and we're going to create a new health check and add in the Honeycomb check for an SLO that's specifically tied to this checkout service. So the first thing I did is I went into the Honeycomb side of it. I'm looking at my checkout service over here. I have all these dependencies that are mapped up to this, and I'm going to create a new SLO. So under the SLO side of it, through my movie magic here, right, we already magically have an SLO created. So for our SLO here, I'm looking at the last 7-day period. My target is 99%, and I'm kind of looking at the historical SLO compliance for this application. And then I'm also potentially using my budget burn down rates, and I'm going to use this data here within the Gremlin side of it to determine the pass fail of the condition of the tests that I'm running in there. So what I'm going to do is first off, let's build this checkout service. So we have this SLO here. So let's go into the Gremlin side of it and build a new health check. So first thing I'm going to do is go up to this new health check piece of it, pick the observability tool that I want. In our case, we're using the Honeycomb side of this. go into the next. And now I'm going to start building out the health check that I want to create on here. So first thing up, let's go and give this guy a name, and then let's go and add in the actual URL. So let's craft this. All right, so the URL piece of this is going to be based off the API from the Honeycomb side of it. I'm specifically looking for the checkout service, and then I have basically the identifier for this SLO that I've created. So if I go back to this, you'll see that the same identifier is up here in the URL, and I'm basically using that to craft up this call. So we'll call this our Honeycomb checkout service SLO. We'll test our connection on here. And what we're looking for is a series of data to come back from the observability system that's going to allow us to set some kind of parameters on here for what is pass or fail. In my example here, right, I have a current budget remaining of 100, compliance of 100. My success evaluation criteria is I expect a 200, success code coming back from the Honeycomb side of it. I want to get the response within 5 seconds. And then I'm going to use compliance here as my value. So we'll say compliance is greater than, and let's say, I don't know, let's be pretty strict. We'll go with 99.9%. So I'm assuming that my compliance is going to stay at 99.9 whenever I run this. So if I do the test evaluation, I'm currently at 100. So no surprise there. I passed this test, right? It came back with 500 milliseconds, status code of 200, and my current, compliance rate is 100. So let's create this health check. So now a couple places we can do this. So on the service side of it, I can go back into my checkout service. And under these health checks, I can add my new health check on here. So I'll put my Honeycomb in here. And now whenever I'm running these tests on here, so the scalability CPU, scalability memory, disk IO tests, right? It's going to go ping Honeycomb and the Dynatrace side of it in our example here to basically look for the overall health of the system. If any of those fails, these become a fail condition on these test results, and that would ding my score. For the demo purposes, to keep things short so we don't run these 15, 20-minute tests on here, let's create a custom scenario with a health check in it that's going to go test what happens if I have an outage on this checkout service. So we'll call this checkout service outage. And our hypothesis is here, when I have a 10-minute outage, I stay above 99.9%. And as you can probably guess where we're going with this, we're not actually going to stay above the 99%, but this will be a good example for this. So first thing I'm going to do in this scenario here is I'm going to add a health check where I'm going out to Honeycomb and just saying, hey, what's the compliance score? Using that evaluation criteria we set up before, we're just going to basically ping this every 10 seconds to say, hey, how are we doing in here? But then let's also create a new test. So we'll go into our Kubernetes side of it, go into my cluster, and then I'll go into this OpenTelemetry demo. And we want to target the checkout service. So let's go to this checkout service. From the blast radius side of this, what we're looking at is a deployment on here with a replica set of 2 pods. I'm going to go ahead and target both of those. So we're just going to take the entire service out, assuming that, hey, at this point, we know we're kind of breaking things. But if it's a 10-minute outage, 5-minute outage, right, are we still within our objective on here? So let's start with the black hole test, and we're just going to block all the traffic on here. And let's run this for, let's say, 10 minutes as an example, and we'll kick this off into the background. All right, so now that I've created my scenario on here, I've got the health checks associated, a black hole test on here. Let's save this scenario up, and then let's give this a run. So what's going to happen here is we're going to start up our checkout service outage scenario on here. First thing we're going to go do is go look onto the Honeycomb side and say, hey, all right, I see that my compliance is 99.9%, is my, what I'm expecting, but I'm actually getting back a 100 on there. So what we want to go do then is let's go to the store itself. And now that we have this outage on here, let's go shopping and let's add some binoculars on here. Let's go 6 binoculars, and that's probably good enough. And yeah, we'll just go with all the defaults on here. It's blank filled in form. All right, so when I go to place my order on here, from the demo side of it, right, I'm hitting here, doing the typical user, action, right? I'm just clicking and clicking away on the place order. Nothing's particularly happening on here. From the other experience of this, right, I'm still seemingly able to go browse through. I'm seemingly able to add things to my cart. But now if I go back onto the Gremlin side of this, right, we've added this black hole test in here. So at some point in time, right, we're going to start getting a degradation of service on this, and it's going to start dinging our compliance score on here. From the user's perspective, they can still browse around on the main store, but the checkout service piece of it, right? While I can still add things on there, the checkout service is out of commission on this. And so the idea is that we're going to use that health check piece of it in there to determine when to stop this test. So this does really two things. It sets the pass fail condition for us. It also sets basically a circuit breaker, if you will. When we see a failure condition come back from the honeycomb side of it here, right, where our compliance drops down to some certain percentage, that automatically triggers a rollback of this test, right? We know we've already violated the conditions that we set for success, so no sense in beating the system up any further. So that automatically stops the test on here. So in our example here, well, it's good timing. We got a failed condition on this test that we were running on here. During this run, I had a valid response back from the API. I got my 200 response, came back at 296 milliseconds, but now my compliance has fallen to 99.06. So I fell below my threshold in here, maybe an extreme threshold, I suppose, for this example, but it is a full outage on here. So instead of running for the entire 10 minutes, right, we stopped it around the 2-minute mark because our compliance fell down to this 99.06. Now we could go into kind of the honeycomb piece of it, right? Dig through the traces, see what happened, but we kind of already know what happened, right? We caused an outage on the checkout service. So if we go back to this side of it here, right, I should now be able to go back into my carts. That's already still there. Should be able to go and place my order, and now my order is now complete now that that test got rolled back. So kind of a simple example on there, but I think really the key for this one is by using the SLO side of it, you get a really good look at the overall compliance score and the overall settings for it, because you can add a lot of different items inside of that SLO. But you can also use metrics for like CPU load. You could set up thresholds for the latency for this service. And I think this gives a good example of how you can create that the SLO and use that to do a validation inside of the chaos engineering testing. So, all right, with that, Andre, I think we're good for the demo side of it.
Yeah, awesome. Thanks for running through that. Get my slides back up if I can. All right, so that's pretty much the presentation portion of this session. While we wait for questions to roll in, I just wanted to cover a few final thoughts and a few final housekeeping items. If you want to see which observability tools are supported by Gremlin, or you just want to jump right in and start creating health checks yourself, check out our documentation site with the link on the page. We have a health checks page that has a complete list of all the different tools that we support, and just click on them for instructions on how to connect them and get them going. And if you found this session useful, we'd love to see you in one of our upcoming ones. We post all of our scheduled sessions and topics on our website at gremlin.com/office hours, and they're all free, just like this one. This is also where we post recordings from previous sessions in case you want to watch those. But lastly, I don't know why my video turned off. Sorry about that. Lastly, again, these sessions are for you. We want to know what topics you're interested in, what you want to hear about, what you want us to cover, what questions you want us to answer. So if you do have any suggestions, I believe there's a short survey after this session, or you can always reach out to us at contact@gremlin.com, and we'll be happy to hear from you there too. To get one question, is a health check required? For reliability tests, like Jason showed us, health checks are required, mostly because that's the way that we use to determine whether a test has passed or failed. But even for regular just chaos engineering experiments and scenarios, I'd still recommend including it, because again, that's the way you have insight into your system of whether or not it's healthy or whether or not it's still available. So while it's not required to run those kinds of tests, I do still recommend it. As far as using health checks built in the application, do you mean built into the application that you're running or built into Gremlin? So if your application has endpoints that you can use to ping remotely, okay. Yeah, then what you can do is you can use one of Gremlin's native integrations, like with Dynatrace or Datadog. You can also just build your own using a custom HTTPS or REST API one. And if you have an observability tool that's, that Gremlin doesn't actively support right now, or if you want to ping your application directly, you would use one of those custom health checks and define your parameters like your URL and your success criteria, like Jason showed. So, great questions.
There was a question on Google Autopilot. So that one's an interesting use case for the autopilot side, similar to like an ECS Fargate on the Amazon type side, right? The real idea there is you're offloading the infrastructure management to a third party, in this case, like the Google side of it. And so when you talk about like doing this infrastructure level testing, generally the way Gremlin operates is installing an agent in on the infrastructure piece of it to implement some kind of fault in there. For the autopilot side of it, we do have access into the Google infrastructure to actually implement tests inside of that. You need to kind of talk with us a little bit and then talk with your Google account executive to get that functionality enabled in the environment. It is not on by default, but we can run similar tests that we were doing in this webinar in the Google autopilot infrastructure as well.
And here's actually a great question. Does Scrum capture how long it took a service to recover? I don't think we do, actually. We can tell when the system goes down, but essentially, I believe the health check stops after that point. Jason, do you have any more insight to that? Feel free to jump in.
Yeah, I mean, the health check failure is designed to trigger like a rollback mechanism. However, in those scenarios that we were looking at, when I added the health check in there, you can also add API calls into that scenario itself. A good example of why you'd use that is I want to be able to run some kind of chaos test in there. I'm going to check with my health check to make sure that everything's working along the way. But at the very end of the test, I'd like to give it a, let's say, 5-minute breather and then make some kind of API call to say, hey, did the system recover correctly? So while it's not directly measuring the time for the recovery side of it, you can use that to determine, hey, is the system back in a healthy state? If that piece comes back failed, now you know, hey, even after I gave it 5 minutes, the system's still down. So we've got to go do some investigation here, AKA it never recovered. So we can kind of detect, hey, things never got back to a steady state, but not necessarily telling you exactly how long it took to recover, because typically the tests, when we get a failure on there, the test is over, right? And so we're no longer instrumenting in the environment.
Yep. And one thing you could do, and this is a bit of a manual thing, is we do record when the test stopped. And I also believe we record when the last health check ran on a test. So you can use that time to sort of correlate with your observability tool to see when the system came back up, and that'll tell you how long it was down for. So again, it's a little hands-on. It's not quite an elegant solution, but it is a way just to tell quickly. Great questions, though. All right, I don't see any more. Oh, I assume you can also integrate with Amazon CloudWatch monitoring and management services. We can. Those intelligent health checks that I showed you earlier, or I talked about earlier, they actually use CloudWatch, I believe. But also, if you want to use just CloudWatch on on your own, or you want to use a custom metric, you can do that too.
Yeah, I'd say while you're running like a CPU test, as an example, during like in the logging side of that, and when you go into the the status page for that test, there's a direct link into the CloudWatch metrics if you're running on AWS, obviously. There's a direct link into the CloudWatch metrics that we're pulling from directly to evaluate what the CPU load is. So when we say, hey, load the CPU up to 80% or 90%, we're validating that piece of it with the CloudWatch metrics themselves. So it's kind of a multi-pronged approach there. One allows you to do the intelligent health checks that Andre described, but also we pull those metrics ourselves to evaluate the current state.
Amazing. Future office hours using Terraform to deploy Gremlin to Kubernetes. Ooh, I'll have to give that one some thought. But thank you for the suggestion. For what it's worth, we do offer a Helm chart for Kubernetes. So it's not quite as useful as just having a Terraform chart, but all right, awesome. Well, thanks everyone for joining. Hope you learned a lot during this session. Again, if you have any questions afterwards, comments, requests, feel free to reach out to us through our website or through the survey. Always happy to hear from you. In the meantime, enjoy the rest of your week and have a great Thursday.